we've got particles at A and particles B. So A, where it's a gas, we want them spread out like this, but it's important that you remember it's only the water that's evaporated. How do we know it's only the water? Because in the question it says how we can separate water from the ink. So it's the water that ends up here. And obviously in the liquid form, it's this over here has condensed. So again, there shouldn't be any ink in it. And a liquid, it looks like this. So a liquid is basically particles touching together. They must be touching, but they can't be in nice, neat rows. The regular arrangement is disrupted. You can imagine if this was an animation, all of these would be moving and sliding around each other. That's what a liquid is. Changes of state between the three states of matter are shown in figure 8. Solid, melting to liquid, evaporating to gas, condensing to liquid, freezing to solid. The changes shown are physical changes. So that's literally melting and freezing. Anything which involves a change in state is a physical change. Explain why these changes are called physical changes rather than chemical changes. Well, a chemical change is when a new product is made. You're not making anything chemically new. When water freezes, it becomes ice, which is still water. When it boils, it becomes steam, which is still water. It's still H2O. The other thing is these are reversible, so you can turn ice back into water. But take something like if you're frying an egg, which is a chemical change, you're chemically changing the proteins. You can't get the egg white back from a white state back to its sort of transparent state. That wouldn't happen. That's a chemical change. So the two things you would say is no new substance is made in a physical change, or you could say a new substance is made in a chemical change. That's the converse point. And it's easily reversed, or it can be reversed, whereas a chemical reaction is very difficult to reverse. It's not impossible,